In a neural network, you could have thousands of inputs changing all at once. How on earth do you measure the slope in a 10,000 dimensional space?
You use the partial derivative. It sounds intimidating, but the idea is simple. If your function depends on a bunch of variables dashed by 1, by 2, by 3, and so on, the partial derivative with respect to by 1 just means you pretend for a moment that all the other variables are constants. You freeze them.
So you're just measuring the slope along one single axis at a time.
Precisely. And once you've done that for every single input variable, you collect all those partial derivatives and you bundle them together into a vector. That vector is the gradient. You'll see it written with that little triangle symbol in the block.
So for our example, the function f of x and y equals 5x squared y. The gradient is a vector with two parts, the partial with respect to x and the partial with respect to y.
Correct. So to get the partial with respect to x, you treat y like a constant. The derivative is 10yx. Then, for the partial with respect to y, you treat x as the constant. The derivative is just 5x squared.
So the gradient vector is just 10yx 5x squared.
Exactly. And that vector points in the exact direction you'd need to move both x and y to get the biggest possible increase in the function's value, the steepest path up the hill.
Okay, that makes sense for one output, like a single loss value. But